Hi everyone, welcome back to my channel and to the series of Python Unleashed. My name is Ajay and today's topic is we are going to look at local and global variables. We have just, by my previous 2 or 3 tutorials, we've been working on functions and we have learned a lot of the features of a function, what a function is, and the types of arguments that we have gone through. Now we are going to understand about the local and global variables, and very important is how immutable and mutable variables as parameter they behave when we talk about local and global variables. Okay, so we're just going to start. So let us define a function. Okay, let me just define a function. I will just call that as function itself, and let me have one variable out here, and then just let me change the value of that particular variable, that is the parameter, and then I'll print that parameter. And then outside, that is in the main function. Okay, in the main function also I will have a value that is x, and then I'll give a function call to this function and I will pass the value as x. And then outside this, not outside, after that I'm going to print the value of x. So the value of x is equal to, that's the message, and x. Okay, so it looks good. So this is a call to the function, this is the function definition, and the value of x will be passed to a. Then I'm changing the value to 5. So since these are same values, I'll just make this as 10. Okay, and then I'm printing a. Then from here it will return to the main program, and then we will print the value of x. Now let us just see the output for this, and one by one we will understand it. So I'll just name this as local.py, just a name of my program, and then you can see the output out here. Okay, I'll just print a message out here also that the value of a is equal to, and then comma. Okay, now let us just run this again, and now you can see that the value of a is 10 and the value of x is 5. Now, in my previous tutorials, I have told you, I've just taken a summary of this local and global variables, that whenever you pass an argument x, so only that value of that x will be passed to a. Since this is a mutable variable, okay, if your concept is not clear about mutable variables, there are so many tutorials that I have explained the concept of mutable and immutable variables. Since this is an integer variable, it's a mutable variable. So x is basically only pointing to this value 5. Okay, now let us understand. Okay, if we want to see that, the memory location towards which x is pointing, so I'll just print that that using the function id. Okay, the value of x is so and so, and I'll just add, and the memory location is, and then I will say id of, okay, id of x. Okay, and the same thing I'll do it over there also. Just copy this. Okay, I'll just copy this one and just paste it over here, comma, and this I'll make it as a. Now what id will do, id will basically will show you that memory location, the address towards which these two mutable variables are just pointing. Okay, now if I run this program, okay, you can see the id, that is, okay, let me just make this bigger. The value of a, okay, the value of a is 10, the memory location is so and so. Okay, this is the number that we have for that memory location, and the value of x after the main program, this was the call to the function, and this was, when the controller came back to the main program. So the value of x is equal to 5, and the memory location is so and so. So you can see the IDs are different, isn't it? The IDs are different. Okay, let me just here I will print, let me give some messages that back to main program. Okay, and one more message over here, that is I'll just give the message like inside the function. Okay, inside the function. And now I will run this, and you can see the output that is inside the function. So this is the first function called. I'm passing the argument as x, that is the value is 5, and then it will jump to this function, it will print inside the function, then the value of a is changing to 10. Okay, now what I will do is I will just remove this. Okay, I'll just remove this. At this point you can see that we had two different memory locations. So a is pointing to this memory location and x is pointing to this memory location. Now what I did is I just removed that a. I'm not trying to change that value. Okay, and now we will run this program. And here it is. You can see the memory location of a and x is absolutely the same. Okay, it is absolutely the same as you can see over here, which means that x and a are both pointing to this memory location which has the value 5. So in mutable variables, if you have the same value, so if there are two variables having the same value or four variables having the same value, in that case all the four variables will point to the same memory location. Understand it? Even if I make this as a, okay, and this was the kind of condition I took in my one of my previous tutorial. What if we have the same variable names? Now over here this is a and even this is a, and I told you in my previous tutorial that these two a are different a's. Okay, this a is local to this function and this a is actually a global variable, since this has access to the entire program including this function. Understand it? Okay, so any variable that is defined inside a main program, such a variable will be called as a global variable, and any variable that is inside a function, so it becomes local to that function. So this a is local variable. And as I again repeat, these two are two different variables, though the name is same. Now if I run this program, and you can see the output that this a that is inside the function is 5, and also x. Okay, this message I want to make this as a. Okay, and you can see this a is 5, and then you can see the memory location out here. That's the location that a is pointing, but this is a local a which is local to this function, and this a is a global variable, and even this global variable is pointing to the same memory location. Why? Because they have two different not the two different, they have the same value. So if they have a same value, then they both are pointing to the same memory location. And if I change a is equal to 10 over here, and now if you run this, okay, now you can see that this inside function, this local a, now has the value 10, and now you can see that's the memory location. And for the global a, you can see we have a different memory location. So this proves that these two a are actually different variables. This is a local a variable and this is a global a variable. Understand it? Okay, so by this we can prove that these two a's are different. Okay, so this is how you can prove that, how even if the variable names are same for a local variable and for a global variable, they are two different variables. Understand it? Now for example, as I said that this global variable is accessible in the entire program using the functions also, including the functions, I mean to say. So what if I just remove this thing from here? Okay, I'm just removing this thing from here, and now what I'm doing is, okay, what I'm doing right now is I'm just printing the values. Okay, printing the values. Okay, so in such a case, okay, if you run this program, okay, and then you can see that both the memory locations are same, isn't it? Now if you want to access this a, okay, for example, this is a, let me take one more situation, that is x is equal to 10. Okay, Okay, now let us make this thing more interesting. X is equal to 10, and what I will do is I will try to print X over here. Okay, and I will say that the value of X is equal to comma X. Now let us see, just run this, and then we will understand what is going on out here. Okay, you can see that first thing that we have is there is no error. Absolutely there is no error. Now what exactly went out here, that is, we are going to understand it. Now the thing is, X is a global variable, and I straight away use that variable in this function. Okay, now what Python will do, Python will first, when it encounters this variable X, so basically it will try to check the definition whether it is defined or not. Since there is no X defined under this function, okay, then what Python will do, Python will try to look for this variable in the global area. Okay, please understand this. Okay, if Python does not find a definition for a variable in a function, so it will check in the global area. So in global area, once it checks the global area, it finds a variable X which has the value 10, and then it will take that value and print that value. So you can see the value over here, that is X, it printed 10. Okay, and then this is a function call. Okay, there is a function call. Inside the function, it will check for this X. It is not finding the definition, so it will check for the global, it will access the global area, and then it will check for the variable X, and there is a variable X and its value is 10, so it will print 10. Okay, so this is how you can access the global variable inside a function. Okay, I want you to understand this, how this rule is followed. Again I repeat, if a variable inside a function, there is no definition for this X, a local definition, so Python will try to search for a variable X into the global area, and in global area it finds the variable, then it will access that particular value of for that particular variable. So it's 10 out here, so it will print 10 over here, you can see, right? So this is how you can access the global values inside a function. Okay, and this A and this A are anyway two different A's, understand it. Okay, now even if I make some changes, for example, if I make a change that is X is equal to 5 over here, okay, and now we will see the output, and now you can see the X is 5, and over here that is X is, over here the X is 10, you can see. Okay, let me just make this as X. Okay, and let me just run this now, and you can see that the value of X now became 5. Now what will happen over here? Over here Python will define a new variable, isn't it? So this is a local variable, understand it. So this will become a local variable now, since I have defined a variable. So Python will consider this as a local variable. So this becomes a local for this particular function. So this X, again I repeat, this X and this X are now two different variables. Since I've just assigned a value, I defined a variable, so Python will create a local area for this X, and so it will print the value 5, and then when it comes outside this function and it prints the value of X, so this will access this global variable and not the local variable, understand it. This has a life. X will have a life only when this function is active. Once this function gets over, it has no existence. This X will have no existence. So once this function gets over, it comes into the global area, then it will find a global X, that is this one, so it will print 10 out here. So you can see it printed 10. Okay, so just understand how things are actually working. I'll just remove that one statement so that we can only have the X. Now you can see this is X5 and X is 10 out here. Okay, so this is how the things work. Now what if I want that, I should be able to change that global variable, the value of that inside this function. Okay, I want to change. Suppose if I make these changes, that is x is equal to 5, so this becomes a local variable. It creates a local variable x, so it does not change the global x, isn't it? So in this case, what I will do is I will use the keyword that is global. Now global is a keyword, and I say x, global x. Okay, and now let me just run this, and what will happen, you can see the output. What happens with this global x, that you are indicating to Python that I'm using this x, which is a global variable. So even if I make any changes to x, those changes will be actually reflected to the global x. Okay, so this is an indication to Python that do not create a new variable x. In fact, just use this global x. Okay, so in this case, Python will use the same x that we have in the main program. This is a bit confusing for the new beginners and the people who are just about to learn programming or understanding functions. So local and global variables kind of becomes a huge task for them to understand, but you just need to practice onto this. Okay, understand with this statement. Okay, we just tell Python that do not create any local variable. Even if I give some value to x, do not create a local variable x. In fact, just use this global variable. So what is happening over here, that the previous value, that is the global x value, is 10, and then I'm giving a call to this function, and then what is happening is, forget this a. Okay, right now we are not concerned with this a. We are not doing anything with this a. We are just concerned with this x. So when I say global x, Python actually considers this global x. So when I say x is equal to 5, in this case Python will actually make change to this global x, and so you can see it printed 5 out here inside the function. And when this function got over and it came to the main program, even then it printed the value as 5. You can see over here. Why? Because with this statement we just indicated, we told Python to use the global x, and so if you make any change to x, it will be reflected into the global area, to the global variable. Understand it? Okay, so this is how the entire working of local and global takes place. And understand, you can always use a global variable inside a function, but the moment you try to assign a value for an immutable variables, then in that case it creates a local variable. Like this, it creates a local variable. But if I remove this again and just try to access the value of x, which is not inside the function, so in that case Python will go for that global access, take that value of x, and it will print over here. Okay, even if you want, like, some other situation where if I'm just using a if statement, like if x is equal to 10, some condition, even in this case it will not find x, a local x, so it will go and check in the global area, and there is a x, so the value 10 will be compared over here. Okay, so this is another way where you can access the global variable. But if you give some value, then it creates a local variable. If you don't want it should create a local variable, then just use this global keyword and just name that x. They will name the variable of the same variable name that we have it in the main program. Okay, so this is the entire thing about local and global variables. But let me tell you, as I said, that we are going to understand immutable and mutable variables as parameters, right? So this was a mutable variable, a simple integer variable, which is a mutable variable. Okay, but what if there is a list? Okay, now let us just delete this entire thing. Okay, and let me delete this, and let me make this as L. Let us take L, which is a list. Okay, so I am defining a list, and as you know, list is a mutable data type. So I have a list and it has the value like 1 2 3 4. Okay, and then I'm passing that list, and over here I can have any name, that is x, a, or anything. So over here if I pass this L, so this x will be having this this the list from this L to x. Okay, and then, so since now x is also a list, so what I can do is I can just say if L, oh sorry, not over here. Okay, just inside this, x of 0, that's the index value, and I keep that as 5, and then I print x. Okay, and then once I give a call to the function, okay, I'll just print the x out here, that is not x, the L. Okay, and I'll just print the list, that's it, no message. Okay, okay, that's it. Now let us understand this working of a mutable data type, not mutable, immutable, sorry, mutable data type. Okay, since a list is a mutable data type, so we are going to understand its working. Okay, so let us run this. Now you can see something really interesting output out here. Okay, you can see over here this L I passed to x, so x of 0, that's the index value, and the value I changed to 25 since this is a mutable data type, isn't it? And then again, after the function gets over, again I'm printing L, and you can see both the outputs are same. The print statement of the function and the main program, you can see both the list are same. Okay, now why we have same? As I said that in my just now in this tutorial, I told you when you pass something, just that value gets passed, isn't it? But over here this is a mutable data type. What is happening over here? Now to understand this situation, okay, let me have one x is equal to L. Okay, and let me just print. Okay, now this is, I'm doing this in global, isn't it? And x. So when I say now this statement, just understand this statement. Okay, this is just like I'm, you know, just copying the reference. This is like, you can say I'm just copying the reference. Okay, the reference. Okay, reference means it's just that memory locations are same. So this statement will not create a new list x. This statement, when I say x is equal to L, so the, you know, the list of that is the list L, so x will be also pointing to the same memory location where L is pointing, you can say. Okay, or you can say what memory location L has, x will also have the same memory location. So any change, okay, if any change if I make, for example, over here I make a change of 0 as 35. Okay, let's forget all this for a moment, and this one, okay, let me just forget this. Okay, and let me run this, and you can see both L, this is L and this is x. So whatever change I make in x will be reflected in L, and even if I make any change in L, that will get reflected in x, understand it. So if I give L of 1 is equal to 100. Okay, and now you run this, and okay, so okay, now just L of 1 is equal to 100. Okay, now just run this, and you can see both the list are same. This is L and this is x. So whatever change I make in x will get reflected in L. Whatever changes I make in L will get reflected in x, because x and L are actually the same, and because they are just the same memory location. But if you want that x should be a different list altogether, so in that case we use the function that is the list function. Okay, we use the function that is a list function. This will actually create a new copy for x. Okay, now if you run this, and you can see the output, this is L. Okay, if I make a changes, L of 0 is 35, so over here it is 35, and L of 0 over here it is 1, so you can see it is 1 the same. And then I made a change to L of 1, that is 100, and you can see 100 out here, but x is the same value, that is 2. Okay, because this actually creates altogether a new copy, so x and L are now two different lists. Okay, now the same scenario you can see when we give a call to the function. It is the same scenario that is taking place. L is getting assigned to x, so L and x are actually the same list, isn't it? If you just delete this, okay, I'll delete this also, and now you can see the same scenario we have is L is getting assigned to x, so this is x is equal to L, so x is just another name to L when we talk about list. Okay, so whatever changes if I make in this list will get reflected in this global x, understand it, and whatever change if I make in any change, it will get reflected in L, it will get reflected into X. Okay, so this is the main concept. So so whenever you working with mutable variables like a list, understand whatever change you make in that global in that local to that function, it will be reflected into the global into that global area also, into the main program also. So this is the whole concept of local and global variables, and understand that you need to practice a bit. Okay, and one more suggestion that I would like to give, that as far as local and global variables are concerned, do not make things complicated. As a programmer, you need to keep your things pretty simple. And so my suggestion is, you always keep the local variable as local and global as global. Do not, you don't, there is no need to access the global variable into the local function. Okay, we kind of, as far as possible, we need to avoid such a situation. Okay, so that's it for today. Bye for now.